Time for section 4.4, and we're going to look at the differences between physical and chemical changes. All right, so nice little diagram that we've got here, nice little cartoon images, but this really demonstrates to us the differences between physical and chemical changes. So essentially what we are getting here on the left is going to be different from what we get over here on the right. So on the left, we've got some physical changes. On the right, we've got some chemical changes. So the difference between physical and chemical changes are going to involve a change in the chemical bonds, okay, covalent bonds, and in some cases ionic bonds. They will either be broken, formed, or both in a chemical reaction. But over here, bonds, in the sense of sharing the electrons, being held together through the sharing of the electrons in a covalent bond, they're not breaking. Okay, what is breaking or what is changing would be the intermolecular forces. So in that case, the melting ice, so heat is being absorbed by our block of ice, and the water is transitioning from a solid to a liquid. All that means is that the intermolecular forces, the hydrogen bonds, are breaking between the water molecules. And remember, hydrogen bonds are not bonds, they are just intermolecular forces. Strong ones, but IMFs nonetheless. And that same thing is happening when you chop wood, when you shred paper. We're not changing anything about it. This is still paper, this is still wood, it's just smaller pieces of them because we are breaking the forces that are holding the molecules that would be holding the paper or the wood together. However, over here, these are chemical changes, okay? So bonds are being broken and formed. So the rotting of a banana, the burning of wood, so the combustion of the wood that we have here, the acid-base reaction between vinegar and baking soda, the reactions that occur in the explosion of fireworks. Okay, what's happening? Bonds are breaking, bonds are being formed, but we are going from one thing and we are getting something new, okay? Something that we cannot necessarily get back immediately without manipulating those bonds once again, okay? So with the burning of wood, we've got our organic matter within the wood, we've got the oxygen in the air, and through the high amount of heat that we've got here, the reaction between the wood and the oxygen is occurring, and carbon dioxide and water is being formed and released. With the vinegar and baking soda, okay, there's the reaction between the acid and the base, and in that reaction, we're forming a salt and then liquid water. Okay, we would not be able to mix them together and then get the vinegar back out very easily. Okay. And then once a firework explodes, it's going to be a little difficult to get all of that back into that one little thing. So, yeah. All right, so as we've been talking about throughout this unit so far, chemical changes are just processes where chemical bonds are breaking or forming or both. So the atoms are being rearranged relative to one another. So they're either coming together, they're either breaking apart, or maybe they're breaking apart and then coming back together with something else. So when a chemical reaction occurs, new compounds are produced. So we will have a product that is fundamentally different from any of the reactants that we had. We can only reverse a chemical change through another chemical reaction occurring. Physical changes just manipulates the intermolecular interactions. So energy can be put in to do that, or energy can be taken out to do that. So if we go one way, we could reverse it and go back to the state that we were in before. So the big thing is changes in phase, going from gas to liquid, liquid to solid, or solid to liquid, liquid to gas, so on. All of those processes are phase changes, so that they occur as intermolecular forces are being formed or broken as the substance, whatever it is being heated or cooled. We could also be talking about changes in shape. So maybe like hitting a piece of metal to change its shape, or something else. Essentially, you're just moving the atoms or molecules around within the substance. All right. So the big thing is that bonds are not forming or being broken, and we are not forming any new compounds. Water that melts is still H2O. Okay. Dry ice that sublimates is still carbon dioxide. So the molecules themselves have not changed. They have just changed in terms of their intermolecular forces relative to one another. Well, there's a little bit of disagreement. So, why not just complicate things a little bit? I don't really know if you will necessarily need to know this, but it's helpful. So there is a little bit of disagreement about some processes in which bonds are broken and whether they would actually be considered a chemical change or a physical change. So like the one under the most debate is just the dissolution of salts in water, where they break apart. So the ionic bonds between the positive and negative ions, whether breaking those apart and then forming new ion dipole interactions with the water molecules, whether that's actually a chemical process or not. Sometimes considered a physical process, as you're just pulling them apart and then forming the ion dipole interactions. So that would kind of fit in with what we were talking about with the physical changes and just the intermolecular forces being manipulated. However, it's not just the IMS. We're talking about ionic bonds, so the really, really strong attractions between the positive and negative species. So anyways, that's it for our physical and chemical changes. So that is all for today. So make sure that you have completed the 4.3 practice problems, and then review what you have done with the answer video that will be posted later. And then also complete the questions on Google Classroom, or sorry, AP Classroom. Goodness. All right, have a nice day.